In this video, I'm going to show you how to perform a flow analysis on your cars. The first step in this process is to go up top here to your Options tab, hit the drop down, go to Add-ins. You want to go down to the bottom where it says SolidWorks Add-ins and check the two boxes that surround the SolidWorks Flow Simulation 2011 software. Then hit OK. You'll notice once you hit that a new tab will pop up right up here on top, and also a new tab will pop up over here. The first thing you want to do is to then click on the Flow Simulation tab and then go to your wizard. That will bring up a new dialog window and will allow you to create a new test, which is what we're going to do today. You want to name your test, your last name underscore test, and then test number. In my case, I have done 4 tests so far, so that's why it has the number 4 here. So I'm going to click Next, and then this will bring up some of your variables. The one we want to change here is your velocity. So you want to change your unit from meters per second, hit the drop down to go to miles per hour. Once that's selected, that's all you need to change. Go to the Next tab. Next, we are going to be performing an external analysis, so we want to change the option to external and then check both boxes to exclude cavities without flow conditions and the internal space of the vehicle. Then once that's complete, click Next. This is the part where we define what material our object will be going through. Since we are testing a car, we are going to have it running through air, which is under the gases option. So click on gases, then air. Double click it to get to select down here at the bottom. Once it's selected, it will pop up down in this box here, and then you can go ahead and click Next. On this page, we do not have to change anything, so all you do then is click Next one more time. Here on this page is where we define how fast our car will be running when we send it through the test. So under the velocity and Z direction, we want to select this and make it negative 300, and then it should change to 300 miles per hour. What that is going to do is, since our Z positive direction is facing away from our car, we want the wind to travel in the negative direction, which would bring the wind across our car, moving from left to right. So once you have your velocity chosen, hit Next. And now we want our resolution better than the typical, so we're going to go and change this from 3 to 4, and then hit Finish. And once that loads, you'll see a box pop up around your car. This box represents the area in which the wind tunnel will be occurring. So what we want to do here is we want to go ahead and change some information about our box. Okay, once you see the box pop up around your car, that again is going to be where the velocity test will be taking place. So the first step to altering the size of this box to fit your car is you want to click on the tab up here for the flow analysis. Then see where it says the input data, you want to hit the plus sign, which would be here, to drop down these options. And you'll see computational domain. That stands for the box. So we're going to right click on that and then hit edit definition. And then when that happens, this box here will pop up. And now on Schoology, if you check our page, you'll see a drop box, and attached to that drop box there's this doc here where it has the computational domain you should be using. So you should be able to go in here and then copy these numbers into this box. So I'm going to go ahead and do that quick, and then we'll continue from there. Now that I've changed my numbers, you can see that the box has shrunk around the outside of my car. So as you can see here, if I compare this document to my existing simulation, that the sizes here match the sizes over here. So every time you run this test, you want to make sure that you are using these sizes. So now that that's complete, I'm going to click the check mark, and that's going to show my box one more time. And now that this is complete, we can go ahead and run our tests. So up top here, you'll see that there's a Run button. Just click on that, and you're just going to solve for a new calculation. Hit Run, and you'll notice down here in the taskbar, a new window will pop up. It might take a minute or two. Right here. Once that hits, you want to go ahead and click on that, and it'll start running your tests. So once that starts, you may or may not have these windows here pop up. If these two windows do not pop up, hit the pause button, then click this Insert Preview, and here you can choose your right plane. You go to your settings, you want one for pressure, then you would hit OK, and you also would want to change one. You want one for pressure, and you also want to change one for velocity. So once you have those two windows, you can just hit OK, and go back to your simulation and hit Resume. And what this will do is this will run your car through a series of tests. As you can see, the number keeps changing here, and this will tell you how much pressure is exuded on your car, as well as how much velocity it can have. So you'll see these numbers will change. And once it finishes, it will stop, and it will say Solver is finished down at the bottom here. So upon completion of that, you can go back into SolidWorks and load those into your actual drawing. So when I do this, I'm going to go ahead and right-click on my computational domain and just hide that, so I don't have to see that anymore. So the next thing I want to do is I'm going to just zoom in a little bit here to look at my car, and then I'm going to go ahead and okay, now I'm going to add the plots or the results of the tests into my drawing here. So first I'm going to do pressure. With pressure, we're going to use a surface plot. So you right-click on your surface plot and click Insert. Once you do that, it's going to pop up here with selection. You want to click on every face on at least one half of your car that was tested. Like so. I'm just going to go along and select every single one of them, including the ones on the back here. And you only need to do this for half of your car because we're only testing half the car. So once you have that, every single one selected, you can just go ahead and hit the green check mark, and it will bring this progress window up. And then once it's completed, you will see a complete model of where and how much pressure is located on your vehicle. One thing you want to do with this is you want to make yourself change your scale over here by just clicking the top number. Since mine's 124, I'm going to change it up to 130 just to give myself an even rounded number to report my results. And I'm going to make sure whenever I run this test that I use that number, so that way my results aren't skewed. So then you can see here by looking at the car where you have low pressure points or if you have an even pressure, which on my car you can see even around the back there's a fairly consistent pressure, which is good. That means there's a nice even downforce on the car to allow it to move quickly. Okay, now that my pressure's done, I'm going to go ahead and hide that so I can add in my other one. So I'm just going to right-click on Surface Plots, click Hide All. The next one we're going to use is the flow trajectories. So I'm going to once more right-click and hit Insert. I'm going to leave this one as Pipes, and instead of pressure this time, I'm going to do Velocity. So I'm going to click on Velocity, and once more select each face that I tested. By rotating around the car. Once you have every face selected, you can go ahead and hit the green check mark one more time. And this will put in how the air will flow around your vehicle. So as you can see, the lines on mine are fairly steady and they're all around the top. They're nice and smooth. There's a little bit of flow issue around the side here. Once more, we want to change our scale. So I'm going to make mine 400 miles per hour. And that'll change the color of your lines. But as you can see, on the whole, most of my lines are right here in the 200 to 300 mile per hour mark. So that right there is what you can do to make yourself a flow analysis.